But give me 1 second. I want to see if this is. Ooh,
Yeah.
there's live button. Oh, went away.
Oh, because you refreshed it? Okay.
Nope. Now it's back.
Yeah, you're live right now.
Although I can't really check for this.
Okay, I'll get it on.
Would have to go. I guess. Because if I'm talking, you'll be feedback. It'd be hard to hear.
But it's like live, remember? So is this audio live too? Yeah.
Well, you could go out and calling. I'll start talking and tell me if you can hear.
Wait, but go to your board and like say something as loud as you would know.
I won't.
Because when we're over there, it's quiet. It's all quiet.
How much have the door shut? Sound check. Wu-Tang.
When you're like over here though, it's pretty quiet.
Okay, but you heard me. You heard me say that, and I've spoken like an outdoor voice.
Yeah, and you do. Sometimes when your door's open and I'm on the like downstairs or something, I can hear you talk.
Yeah, my voice carries. That's why they had me at the UCLA baseball game. They said they asked if he knows anybody with a big voice, and he said that I did. The players. He said that some of the players told their parents, they're like, "Who is that guy?" I was screaming the whole game. And the parents want us to come to the NBA championship.
That's like funny.
Force them get it. But we might go to the Big Ten championship because that'll be much easier to get tickets for.
Yeah.
What'd you think? Did you have your Dr. Pepper, coconut Dr. Pepper?
I did. And you know what's weird? I'm totally a chugger. Like I don't sip on drinks. And I like just finished it. Like just now and I just oh yeah, you just finished it.
I thought maybe I left that.
But there was only like a little sip left. So like
I didn't like it the other day, but I don't know. I really enjoyed it with my lunch today.
I liked it. I think it's because it's like a sweet treat.
That new Dr. Pepper. Creamy coconut. That sounds so bad. Like
no, it's better than you think. No,
that's because you're a well-known communist.
you have to try it first.
Fanta on the top. That's the best soda.
McDonald's has a like orange Fanta high C
cold foam in it. It's so good.
It's really good.
Are y'all McDonald's fans at your house? I mean, not only me, my friends. They think like McDonald's is like the devil. Yeah, basically. It makes you fat, so I like McDonald's breakfast. That's my thing though. The McDonald's breakfast is good.
I like McDonald's breakfast too.
Especially the hash browns. I think I could eat 4 of those.
And a McGriddle. I love a McGriddle.
We also, when they had the chicken Big Mac, did you ever have one of those? Chicken Big Mac? No. I saw it and it just looked too gluttonous. Yeah, it's like
it's so good.
They were amazing. we were going there quite a bit when they had those, and McDonald's up here still had them when everybody else didn't. So we came up to get one, and we were so excited, and they were out. And it was funny. My wife happened to call us as we were ordering it. We're talking to her. She goes, "What's the matter? You guys both seem really down." We're like, "They're out of chicken Big Macs."
Yeah.
But sometimes if we really need it, you just get chicken nuggets and then put it. You can take the meats out, or you can put the. We had somebody ketoing, so we'd all get a Big Mac and take all the beefs out, let them have all the beefs, and then we put chicken nuggets in the sandwich and make our own. They were pretty good. It's not quite the same, but it's pretty good. All right. How many people we got? It's weird I can see myself on there. 18. 18
people? That's so much.
Oh, 19. Wait, did the thing where it looked like it was going up a bunch of numbers and it was for one more. Live chat. So can you not open the chat?
I don't know.
I don't think I can open the chat.
Let me get on it. I'll try to send a chat.
Do you have anybody that you're friends with enough to have a text that is, is watching the video by chance?
Maybe Suchet. You know Suchet?
Yeah.
Maybe I'll see.
Text Suchet and ask him if he's
Wait, Dad, I think you can't make a comment because you're on FISD Wi-Fi. They don't let you comment.
I don't think they let you watch live stream if you're on school Wi-Fi. Yeah, if you're on school Wi-Fi.
I could hear you talking.
Hey, you already have one thumbs up. I'm gonna thumbs up it too.
So am I.
I subscribe too.
Ooh, 36.
36 people?
Yeah. It better be about 150, but like I said, there might be people sharing computers.
Okay, I'm gonna get on my phone and see if I can comment.
If anybody's watching, see if you can put some in the chat, please.
Hey, there is people putting stuff in the chat.
Okay.
I don't think you can see the chat because you're on school Wi-Fi.
Okay, I believe you.
Because it said these people said hi. Wait, Maya's calling me. Hello? You can. Hey, Dad, there's a charger in the corner over here. Is it yours?
No.
Hey, maybe you can give it to that boy that lost his charger. He deserves it.
Well, somebody might be coming back to find theirs. What happens? all the time.
Anyways, yes, you can come pick me up, but I'm gonna. Are you like close? Okay, good. Then yes, you should. Okay, perfect. Okay, fine.
She, I'm definitely.
Mine's gonna come in.
That's a.
See? The people in the chat. I don't know who that is. I don't know who's people. Do you know who that is?
No. Yeah, you never. Yeah.
Well, mine's Bruce Hughes. So.
And mine's David Hughes. I talk crap and people know it is. I'm not very good at that. Get these markers out of the screen. No, now it's down to 22. Now it's down to 20. Maybe people turned it off and they're going to turn it back on. Oh, and also, just go get something again tonight.
Okay.
And if you guys go to Taco Bell, don't give me anything. But if you go somewhere else,
Did you something?
go ahead and grab it.
Okay.
I can make by without it, but
Okay.
is your sister gonna help you study tonight?
And you know what? I was gonna use my income book like as flashcards, and Cooperland literally told us today that we should use our income book as flashcard. But I have to finish. I have 8 pages left, and I need to do my 8 pages.
And you have to turn it in at the day that test.
So my friend said something. Well, Michaela said something about waking up. I don't know, waking up early. So she's not like super sleepy before her test or anything like that, or do you think that's gonna make her more sleepy?
I think you're probably gonna wake up like because of anxiety. But yes,
So too.
I think you should wake up early and we should go get some breakfast.
So she wake up at like 6:30.
Sure.
And then I'll feel like more alive.
We can get wherever you want. We can go to Whataburger, McDonald's, or doesn't matter.
Okay.
Starbucks. Better to get food somewhere else, but
Or we can just eat it at home. We have English muffins.
we have one package left. That was pretty good. I spelled recorded wrong.
Where? Wait.
Record.
Oh. Cord. Whoops.
I've never claimed to be a speller. I claim to be a non-speller, as a matter of fact. It's like if anybody ever asks, you will just say you're my mom.
I got you.
All right, let's sign up. Camera's charging, so we'll run out of juice. Got my list. Calculator. Does my hair look messy? I guess if it looked all nice and neat, everybody would be confused.
No, it's fine.
Remember in the Bob's Burger when he's taking pictures at Thanksgiving and he goes, "What fix your hair? It's my hair." Well, if that's how you want to present yourself on vlog working. Yeah, you're right. Let me see. About 5 minutes. Did you get sushi? Did you get sushi?
No, he didn't respond.
Okay, that's fine. I hope not to, but I might have to have you go out mix. Like if can you see the chat?
I'm looking at the olive right now.
Okay.
I can
I
see
got it on
that.
my phone.
Yeah, get on your.
Actually,
Dad, oh, you're on your phone.
I've gone for my phone twice.
So you can't.
Because that's I go, oh, I'll just get on my phone.
Wait, but that doesn't make any sense about the Wi-Fi though. There's no reason you shouldn't be able to see it on your computer because on my phone's on school. Oh, it's not on Wi-Fi at all.
Where it's on it. But that would be awesome if you can just because then you can just monitor the chat from and then you are my mod. Or the mod. My mod seems a little more possessive, I think. Yeah.
Okay, you're back up to 30. BT dubs.
I mean, it makes sense. I mean, because they probably wanted to watch fun videos while they were waiting.
I mean, yeah,
Instead of sitting there looking at you walking back and forth on the screen.
What am I monitoring? What am I moderating?
Just to look at the chat.
Oh, okay.
But is he like making sure no one says anything appropriate, or is he like telling?
Oh no, I think saying I don't know what to do about that. No, mostly if everybody starts being like we can't hear, or
Oh, okay.
if it stops recording.
I'll check in every once in a while at home.
It's kind of crazy seeing the
guess I'm gonna go with lowercase.
I do it all the time.
That's just a really part of mine.
37. No, now 35. God, if there's only 35 people on this, I'm gonna be. Actually, it doesn't matter. I'll just be glad that those 35 are getting help.
They're gonna get fives.
I got 1 minute. And during that 1 minute, I'd like to point out the question where they think that there's going to be a tree diagram for the probability. If you're in my class, you better have already known this because we talked about it. But here are 3 former questions. And again, you can also go find scoring guidelines and look at those. I think at least one of those, if not both of them, you could also use a two-way table. So it would be optional, but the tree diagram would be nice. And remember, the tree diagram is your work. So that's nice too. And we're going to start right at 5
What's five?
as a symbolism for the 5s that we're going to be getting on the test. The score is a 5. It says 5.
Yeah.
On the real clock.
Yep.
All right. All right. So I'm gonna go ahead and get started. So I just have a big list of stuff. I'm just gonna go ahead and I'm just gonna go through a bunch of stuff. And then again I will try to save it. I just have no idea how long it's gonna take to upload. I would suggest it'll probably take over an hour to upload. And I'm not going to start until I go home and get on the Wi-Fi because the uploading does not like jumping on and off Wi-Fi. I have learned that in the past. Okay, so the first thing that I'm going to talk about is I guess socks. That one should be pretty easy. And remember, it's socks in context. And the socks is shape, outliers, or gaps. I shouldn't spell like this, or gaps. It's actually supposed to be unusual features, but it's outliers and gaps within. And then center and spread. All right. And the shape is going to be your skew left symmetric uniform. Don't say evenly. There is no evenly. But you can say symmetric instead of normal. You really shouldn't say normal. You should say symmetric here because the graph can be symmetric without being normal. And the outliers and the gaps, that's self-explanatory. The center, remember, we're going to say median. We're going to go with median, but please say center. Hopefully you saw in the rubrics, if you say median, then you must give the median. If you say center, they allow for a little bit of wiggle room. And we don't want you to calculate it. We want you to look at it and then gut to say that's what it is. And then the spread, remember, you can use the range. It's not even usually the best answer, but they always accept the range, and the range is by far the easiest. And then context, for sure, got to get those units in there, but context. And it's usually you have to do 3 of these 4 and this one. The context stands alone. All right, so that should be pretty easy. And again, the prediction suggests that you will be doing that on the exploring data. All right. Hold on. Let me mark this as I go. Okay. Probability model. So this would be when they tell us the values 1, 2, 3, 4. I'm just going to make up numbers here. I'm not even going to worry about plugging stuff in. Okay, but we get a probability model. Maybe this is the scores on the AP exam at not here,
right? Well, I guess we wouldn't have that. Never mind. Campus scores exam. Anyway, these are the possible values. These are this is the percentage of times that they happen. So remember to get the expected value and the standard deviation from this. What you do is you plug these into L1, these into L2, and then when we go stat calc 1, and then you got to make frequency list L2 before you hit enter. And then when you solve this, you should say E of X equals, and then you have to show 2 steps plus dot, and then you can say whatever it's equal to. I'm totally making up a number, but I'm gonna say 2.2 feet. Whatever, for whatever reason, that's what that's happening. And then for sigma X, then what you do is big old square root, and then you take the value 0 minus the mean squared times that probability. And then you do that another step. The number 1 minus the mean squared times its probability plus dot, inside the square root, and then put whatever that's equal to. You have to show 2 steps when you backfill in the work. Remember, when the calculator tells us the answers, we backfill in the work to make the stats dorks happy when they're grading our paper. But again, that was also suggested that that's going to be on the FRQ. I will also guarantee that that's on the multiple choice as well. So let's make sure we know how to do that. And if you don't, you better go Google it. How do I get the expected value and standard deviation from a probability model? Or you should see lots of those in our notes. Our notes and our worksheets and whatever. We had one on the test reviews, all that stuff should have that on there. Okay, stratus, and I'm jumping all over the place, by the way. Stratify versus a cluster. So remember, we have an SRS, that's the names of the hat method. Systematic is like every 5th person. The randomization would be how you start. So maybe I'd roll a dice and I get a 6. I start with the 6th person, do every 5th one. That's the systematic. Stratified versus cluster. With this, again, I'm just going to go ahead and guarantee that you'll have a question with one of these two. You will read it and instantly know it's stratified or cluster, but then separating between the two is where it's difficult. Stratified is where I take some from each of the groups. And it reduces variability because everybody is represented. So actually what I do is I take a mini SRS from each of that group, but it's some from all groups. All right, a cluster, also we have groups together. What we do for cluster is we randomly pick some of the groups, but I check every single person in that group. So all from some of the groups. Okay, also another word that they like to use from this that makes everybody, this one, it's I'm sorry, let's do this one. This one, it's different within the groups, but the groups are the same. So again, this would be like, again, if we did like GPA with advisory, every advisory class is going to have some high performing students, some mid, and some of our lesser performing students, not us, but some other students in our advisory, right? So each of the groups is going to be similar to each other, but within the groups, they're very different. That's another thing that they talk about. And in here, the groups are different, but within the groups, they're the same. So again, this one I might do stratified. I might like pick classes. I might make sure I take some from my AP classes, some from my on-level classes, and some from my remedial classes. But the groups will be different. Anyway, they don't do that as much, but definitely some from all the groups, all from some of the groups. So if they say we took the groups and I picked a group and I looked at every single one of the things in the group, cluster. That is definitely one. It's from a long time ago. It's actually pretty easy, but it's because they're so doggone close to each other that it makes it hard to differentiate those two. All right. Bias. Now, I'm going to tell you, we had non-response. Under coverage. I should know this without looking, but we're not playing that game. and response bias. Okay, there's a couple. The college boards expanded this, and I only became recently aware of it. So you might go to the college board and look for other biases. Let's do undercoverage is the one first, and that's when some people have been systematically removed. So if I use the phone book, which you're like, what's a phone book? But we used to have a phone book, right? Or an online directory. Anybody that's not in that online directory cannot be in the survey based on the way that I created it. That's undercoverage. If they choose not to answer the phone, then that's non-response. Non-response can also be if I call it a certain time of the day, some people aren't going to answer the phone at certain times of the day. Where and again, that well anyway, and then response bias is like lying. Also, response bias due to the wording of the question. So it's response bias. This is just a systematic error in the answers for a reason, and then you give the reason why. Response bias due to lying. Response bias due to the policeman asking me if I have broken any laws. Of course, you're going to say no. Response bias due to the wording of the question is the one that they prefer the most. Okay, so when you do bias, remember you name the bias, you explain the bias, and then you have to say whether or not the sample would over or underestimate the true population proportion, the true population mean. Okay, so the example I like to use in class, maybe you've heard it, is there's an art show and there's going to be some paintings of nudes, very tastefully done. Okay, but there's some parents that don't want to see that, so they call it pornography. So they say, "Do you want to have an art show that shows pornography in the blue park where your kids are playing?" And because that way they've worded the question, you're going to underestimate those who are in favor of having the art show, or you're going to overestimate those who are against it. They typically do not prompt you for the over or underestimating. That's their problem. We know we do that. You better write that if they ask it. And if we go back and look at the rubric and it's not on there, too bad. Write it anyway. Um, um, I think that's it for that. For bias. Cumulative frequency graph. Okay, cumulative frequency graph does this, and it always caps out at 100%. Okay, so there's two things I need you to know how to do on the cumulative frequency graphs that are quite common. And here, let me get a few more marks here. And these are by percentages. So like if I do this number, and let's say this is 10, and I drop down 10, and I say it's at 50%. It's not that 50% of them have 10. It's 50% of them have 10 or less. Okay, this graph couldn't do this. We might as well make this a little bit better. Okay, so anyway, so it's and then here, maybe that's at actually it looks about 85%. So 85%, that's not super straight, but you get the idea. And it's not 15, is 85% have 15 exactly, 15 or less. Okay, so two things they really like to do from this is they ask you for the median, and I've already got the median on there, right? That would be 50%. Draw the line straight across, drop down. There's your median. The other thing they like you to do from this is IQR. IQR is Q3 minus Q1. I would again they don't the guy does not predict for 2026 that there is a 1.5 IQR on the FRQ. I would suggest they'll be definitely on the multiple choice then to make up for that. So for the IQR, I would do 75 and drop that down. I'm just going to keep that as 15, just why not? And maybe this one is 6. And I do 15 minus 6 is equal to 9. That the IQR is 9, not 15 minus 6. If they do that on multiple choice, I promise you choice A will be 15 minus 6, or it might say 6 to 15, but the answer is 9. Not because IQR is a single quantity. All right, cumulative frequency graph. All right, inverse norm versus normal CDF. When do we use inverse norm and when do we use normal CDF? This little curve here. Okay, we got, this is our mu and sigma and all that kind of stuff. All right, so if I give you a value that happened, so let's say the mean is 10, and I want to know what percentage is bigger than, let's just say 20. Okay, I want to know what percent. Okay, if that's what I'm doing, that's normal CDF. And the answer we get is the percentages. All right. if I say this over here is the bottom 25%, and I want to know what value makes it so that it's the bottom 25%, that's inverse norm. Okay, also remember this trick, because again, I wouldn't write this question without doing this. If I wanted the fastest 25%, I have to do inverse norm. And for area, it's 0.75. Okay. I want 25% over here. Inverse norm only shades to the left, at least with our calculators. And if you have a brand new calculator, you need to tell it shade left and just answer it like that. I've never seen a rubric where they allow you to say shade right and you would write 25%. And then for mu and sigma, you would just write in whatever mu and sigma was. I don't know. The 10, as I already said, was the mean, and standard deviation would just be whatever the standard deviation is the problem. And that will give you the value that makes that 20. Oh, whoa. That makes that top. We don't do 1 minus, that's the binomial and geometric. We do the hundreds partners for inverse norm. And that one time that was not that big of a deal, but now it's a little bit different. So it's a little bit irritating, but we'll be all right. All right, inverse norm. Okay, speed dating. There will absolutely be a speed dating on the multiple choice. We did it as FRQ because it's going to be multiple choice on the exam, but it will be one of the hardest 10 questions. All right, so I have a population over here, and the mean is 10, and the standard deviation is 2. I have a second population over here. The mean is 15, and the standard deviation is 4. Making up numbers. All right, so on the speed dating question, it was like, oh, if I randomly select one from each, what is the probability that this one will be bigger than this one, or this one will be bigger than this one, or smaller, whatever. All right, so if this is population A and this is population B, first of all, remember this one, the multiple choice, they're always gonna, they do tricks to make us miss it, but we can use those tricks against them to get a good random guess in case you don't have time or you forget how to do this problem. So what's the probability that a rando selected from here will be larger than a rando selected from here? I'm going to say it's not very likely. As a matter of fact, I might need to make those numbers bigger, just to change those numbers around. I'm going to do that. We'll make this one 5. That'll make it actually happen. Maybe we won't get a number that's insanely small. I still don't expect this one to be bigger than this one. It can, but I don't expect it. So I'm looking for answers like this, or maybe this, something small. Okay. Also, in the wrong choices, they will have the hundreds partner for at least the correct answer. We had that on one of the exams. If you just knew it was not likely to happen and it was the only hundreds partner small number, they do that. It's on the exams. They actually give us that free out. Okay. So again, but you should at least be able to get it down to a 50-50 or a 1 in 3 guess. If you just say, do I expect it to happen or do I not expect it to happen? All right. Now, how do we actually do this so we can get it right? So mu of D, and I'm going to do this as A minus B, and we'll come back to that later. So mu of D is equal to 10 minus 15 negative 5. Now, usually when I do this in class, I make that positive, but we're not going to worry about that. Okay, sigma D, that is not 5 plus 4. It's 5 squared plus 4 squared square root. And even though we're doing the difference, that's plus, but we should have known that by now. And I guess I should have picked easier numbers to do those mentally. That's all right. 6.4 I'm going to go with. All right. Now, what's the probability that A is larger than B? If A is larger than B, the results will be positive. So then I'm going to do normal CDF, new mu and new sigma. So here we'll do that first. Mu of D is negative 5. Sigma D is equal to 6.4. And then my lower and upper, it's either going to be from negative infinity to 0 or 0 to infinity. And on this one, remember I said A is larger, so I should have positive. So it's going to go from 0 to something really, really, really large, like 1,000, or much larger if you want. There's no such thing as too many zeros on that. And let's see what we get. Hopefully we'll get at least something. Oh, I got like 21. That's still less. So again, don't worry about the fact that it's going to be real small. but like I said, 79 will be one of the wrong answers. So again, it would be less than 50% for sure. Okay. And then look for hundreds partners. Again, I just assume you did this, but sometimes we have a little trouble. All right. Side part on this one is if they ask what would be the standard deviation of 10. So if I grab 10 of these, what would the and I did the average of those 10, what would be the standard deviation for that? And you do 5 divided by square root of the sample size. If I take more, if I just do one, that's my results. If I'm going to take many of them, I take the individual value of the entire population, divide by the square root of the sample size to get the new standard deviation. That's chapter 7. For 2026, that would have been the unit we kind of don't do. We watch the videos and then that's it. And then we cover this because really that's what you need to know from unit 7. That's kind of why we blow through that unit. Also, everybody, it's at the end of the semester. Everybody's kind of worn out. It's a little morale boost, and everybody, it kind of is a 300. So I don't know. Maybe we don't need to do that. Maybe we do. All right. Okay, we'll come back to I'll do scripts for our interpretations for a minute, but let's talk about R squared for a second. So that's the coefficient of determination. All right, it's the percentage of that for multiple choice, not for the script for an FRQ question, but for multiple choice, it's the variation in Y that's related to X or that's dependent on X or affected by X. Okay, so it's the percentage of the variation that's directly related to the X. Now, when they do this, there's a couple things they like to do. And if you've gone through the multiple choice questions, you've seen versions of this. But what they'll do is they'll say 80% of the variation in Y is attributed to X. What's R equal to? And one of the answers will be 0.8. Okay, but that's what R squared is. So if they say this percentage of the variation in blank that's attributed to something else, that's R squared. So R then is equal to the square root of 0.8, which again, I should use easier numbers so I didn't have to do this. And I should type in the number correctly. .89. And I just blindly put 0.89894. And I just accept that as the answer, right? I don't even that's it. Maybe. Hopefully you're saying out loud yourself. It's plus or minus. It is plus and minus mathematically, but here it's plus or minus. So how do you tell? Okay, if the scatter plot shows a clear positive relationship, then it is. If they tell you, if it's a computer output model, and if you know that the slope is equal to positive, then this number is the positive, not the negative. If the slope is equal to negative, then you pick the negative one. Or the context. And these word questions a lot, it's the context. The last time I remember it being on an exam, it was reading scores and how much TV was watched. And you can't make the argument that watching more TV makes your reading scores go up. And then as a joke, since I'm putting this online, my favorite is to say, like, what if this was talking, what if R squared, okay, I'm sorry, what if R squared was 0.8 and we were talking about the connection between smoking crack and SAT scores. And you can't say that if I increase my crack usage, then my SAT scores would be projected to increase. I would say straight down into the toilet, right? So the context might be the answer. But if they give you R squared and they go to R, very likely to see this, okay, I need you to remember this plus and minus business. Okay, also 0.89 would be choice A. And then down over here, choice D would be negative 0.89. I need you to pay attention to the other answer choices. And if you see your answer, but the sign change, I need you to stop and think, wait, why would it be maybe negative instead? And then if this was a algebra, and then we would have this to get some people to mess this one, some people to mess this one, and some to get this one. But this isn't an algebra test, so it'll just be the positive or the negative. All right, R squared.
App question. We can't say causation because R is correlation, right?
Right.
Okay.
R does not help with causation. And we will get into causation a little bit later. All right. Oh, computer output model. We'll do that in a second. Got that. Okay, population, sample, sampling frame, inference, and cause and effect. Look, I guess we're getting into that right now. Okay, so remember, population is the word. It needs to be population of interest. That helps us determine what's the population. All right. So let's say I want to know what every teacher in the state of Texas thinks about a new law that we're going to do. So the population would be all teachers in Texas. Okay. So let's say that I go to a stats conference and I ask all the I'm sorry, I take a random sample of people that showed up to the AP stats conference. There's no such thing. That sounds horrible, but you get what I'm saying, right? So and I go there and I take a sample of people. Let's say I take a sample of 30. The 30 is a good number of the teachers from the stats conference. That's the sample would be the 30 teachers that I grabbed. The sampling frame would be all teachers at the conference. Okay, that's who I can infer to. I cannot infer to all teachers in the state of Texas. Now, I would suggest that if there was a stats conference, it would be full of the smartest, best looking teachers in the state, but I would only be able to infer to the good looking smarties. Like I can't infer that to the other teachers that teach weaker subjects that are for, for other people, right? I can only infer that. So even though the population was all teachers in Texas, I may only infer my results to the group that I sampled from, which is called the sampling frame. Okay. And then remember to do cause and effect. To be able to do cause and effect, I must randomly assign treatments. And the prediction says they're going to talk about cause and effect by randomly assigning treatments, or they're going to say you can only infer to the population. I mean, from the sampling frame. Sorry, it's a population sampling frame. But who can you infer to? How do I infer to the population? I sample from the whole population. How do I infer to just the teachers at the conference? And I sample from the teachers at the conference. So population of interest. The sample is the people I actually select. The sampling frame, also the people I can infer to, are the actual group that I select from. The other one I like to say is if I, as a teacher at Independence, if I was like, somebody asked me to collect data for the entire district, well, I'd probably be lazy and only select them from Independence because I'm right here. I can only infer my results to Independence High School. I can't say FISD, I can only say Independence High School. I'm going to be honest with you. That's a concept I don't understand why so many people miss it. But I can say I do know that people miss it, and so does the College Board. And guess what the College Board likes to do when they know a question is missed by most kids? They put it on the friggin' test. So let's hopefully we'll be ready for that. All right, experiment versus observational study. So we just had this on our final. So hopefully you had this. This was the Model D car question. They ask you this. So remember, experiment, treatments were imposed. Observational study, no treatments were imposed. And it might be better to say random treatments, but you can just say treatments. Okay, but if that's your answer, you must also include context. So when we had the Model D question, my students all put treatments were imposed or no treatments imposed, and they stopped, and they all got partial correct because they didn't put context. So always put context. And if you're like, oh, Mr. Hughes said I didn't have to put context on this problem. Well, first of all, I probably didn't. And second of all, sometimes Mr. Hughes is wrong. Always put context. Always. Always. And remember, cause and effect, yes. Cause and effect, no, for observational study. Okay, the 4 components of experimental design. Randomization. Again, I should know these without looking, but I'm going to look. Control, repetition, and I'm going to just abbreviate, and compare group. or control group. You can call it control group. They let you call it control group. I don't like to do that because control is different. Okay, so here's the board. And if they had, remember, like we had an example once, and it was like these four things, and it said blocking, and it was really tricky because blocking is good, but it's not one of the four components of experimental design. Okay, why do we have these? The reason we have random is to create even groups. You're gonna try to avoid the bias. And again, you'd say, well, why wouldn't there be even groups if you don't assign the groups randomly? And again, I always just like to use this example is like if you're putting people into two groups and as they come in, you just say go to group one or group two. Well, some people would, this person looks smart. I'm going to put them in my group. Oh, this person is rather attractive. I'll put them in my group. And you're like, oh, people in it. Yes, they do. Yes, they do. They do it all the time. But if I randomly assign the treatments, I get even groups. And also remember that it allows me to infer but that to the population, but that's what we're talking about. Okay, repetition. I think that one's pretty obvious. But why do we have repetition? And that's to be more confident in inferring to the population. All right. So if I do an experiment and I'm doing an experiment on how many flavors of Skittles you can get correct. And I blindfold you with I randomize which order they go in, and I give you those 5 Skittles, and you get all 5 correct. And then I say, all kids can taste the rainbow and know what the flavors taste like. Well, if that happened once, what if this kid eats Skittles every day and he just very familiar with them? Do something once. I got to do it over and over and over again so that I can feel more confident to infer to the population. Okay, and then compare group is like I need to, and again, you got to be careful. Never call the compare group no treatment. There was a year when it said if they say no treatment, then that's not correct. But the compare group receives a different treatment so that I can compare. And we want everything to be the same between those except for like the medicine if we're doing medicine. And again, but the compare group, a lot of time it's a placebo. Placebo versus the meds so that I can compare the only difference. And it allows me to actually see if the difference is from the medication. So everybody with the placebo gets a +10 rating and everybody with the medication gets a +30 or the average is, then I can compare them. But again, I want everything else to be the same, which leads us into control with the compare group. But I need to compare it to somebody whose treatment is everything the same except for the actual item that we're trying to measure. And again, you can call it a control group. It doesn't have to be a placebo. It can be the old drug versus a new drug. But they do too. Or if I'm comparing a new shampoo formula, I think we had some about shampoo, but it's filling bottles. But like I'm going to check to see how it affects dandruff reduction. The new version of Head and Shoulders versus the old one that we use. Is it worth going through and changing all the machines to make the new one? And control is going to be all other aspects are the same. This greatly this again, as long as I do this correctly, I can eliminate essentially all compounding variables. I'm not a big fan of you saying it like that, but you would just mention examples. Okay, the example I like to use for control is I'm doing diet medicine. I have a diet medicine, and my opponents or my competition has a diet medicine. So I give my people diet medicine, and they exercise and eat healthy, and on average they lose 20 pounds. My competition, I had them take their medication, but instead of making them exercise, I give them the newest what's the newest game? The baseball. What's the new? What's the NBA game? NBA Live or something? Whatever. New or new Call of Duty. I'm going to give them the new Call of Duty game and DoorDash coupons, right? And I say, okay, go take medicine. Now, this medicine, this one, on average, people only lost 2 pounds. Now, was it because the medication difference, or was it because this group exercised and ate healthy, and this group sat on their duff all day long playing video games and eat McDonald's? that they ain't even go and get. They got to deliver to them. So we need everything else except for the one variable to be the same or as similar as we can possibly get it. But it's not control group. Control. You're controlling everything else within the experiment. All right. The three types of experiments: completely randomized, block, and matched pair. So, and again, you're definitely going to have something with these. I suggest that the one that's question 2 on the guy's prediction, they're going to explain it completely randomized design. They're going to write it up, and then you're going to answer questions based on it. And then they're going to ask you to switch to a blocking and explain why you would block. So completely randomized design. I have 150 people. I break them up into 2 groups of 75. Okay, and by the way, somebody did this earlier. Like if I had 99, it would be 50 and 49, and you can't say they're not the same. If it's odd, it ain't going to be the same. And no, who's volunteering to get cut in half? I'm not. I like living, so no cutting people in half, right? So then I give this one treatment 1, this one treatment 2, and then I compare the results between the 2 treatments of the groups. Okay, blocking. Remember, the reason why we block is to eliminate one confounding variable. The reason I would do blocking is for medication. Men and women typically react different to medication, or that's very common. Some medication isn't for women or isn't for men in the first place, right? But again, I don't think that would be one where you'd have to block because we'd only do them on the proper gender. But if we thought that was proper, and again, or another one, if we were talking about cell phone usage, okay, and I might be like, okay, I need to group people by age because I know older people are less likely to be on their phone all day than younger people, and not me. I'm on my phone all day sometimes, right? But I'm just saying there in general there would be a difference based on age. So blocking, you block first, and I'm going to do men and women. You block first, not randomly block. You block with a purpose. What purpose? To eliminate gender as a confounding variable. And then let's say I start with 150, and let's use easy numbers. There's 100 fellas and 50 ladies. Then I would do 50 and 50 and compare. And I would do 25 and 25 and compare. And if they ask you, to explain this out, you need to mention that I would compare the 25 ladies of treatment 1 with the 25 ladies in treatment 2. Same for the fellas. I do not check male 1 versus female 2. That wouldn't even make sense. And I know nobody would think that, but you actually specifically have to say who you're comparing in the problem. But again, remember, we block before we randomize. Block before we randomize. I can almost promise you that statement will fix a problem for you. Might be multiple choice, it might be the FRQ, but hopefully you will hear those words ringing in your head when you see that. Block before randomization. Dr. Callan told me a long time ago to make sure that that's in their head, and it shows up all the time. All right, matched pair design. Matched pair design is when out of the large group, you take 2 at a time. For some reason, not random. You are pairing people together because they have some similarity that you're looking for. The last time it was on the AP exam, they were twins. So they're not going to make it confusing whether or not it's going to be clear as day which ones they want. It's just going to be you writing it all out. So it's not like you're going to write and be like, I can't tell if that's matched pair or block. Well, it's going to be because you don't know your stuff. But if you know your stuff, it's going to be really obvious. Like twins is clearly not blocking in 2 groups. We got the twins together. All right. And then each one gets 1 treatment. And then I compare only within the pair. Only within the pair. So that's one type of matched pair. Okay. The other one is each subject gets both treatments. Okay. So my examples I like, 2 examples I use commonly. One is before and after. I like to call it before and after. So let's say from January to through to July 1, we're going to take Advil. Okay. So whenever I get a headache for the first 6 months of the year, I'm gonna take Advil with a big old glass of water. I'm gonna start my timer. I'm gonna see how long it takes me to get my headaches to go away. And then from July 2nd to December 31st, and I don't know if that's exactly the breakdown. You have to excuse me for that. We'll do Tylenol. And I'll do the same thing. And then I'll compare my results of Advil versus my results for Tylenol. Oh, by the way, this reduces most confounding, or I don't want to say all. I don't want to say all probably, but a vast majority or almost all confounding will be reduced. And when they did the twins, they talked about the biological, they're very similar to each other. They live in the same house, they have the same parents feeding them food, that they the same, probably mostly the same habits. So you'd have a lot of confounding variables that would be reduced, not eliminated. Excuse me, not eliminated. Eliminate one, reduced most or all, but don't say all. Okay. And when I do this one, the reason why this one would reduce variability or confounding is, like, for example, most times headaches are by dehydration. If you're dehydrated, you get a headache. It could be because you hit your head, I suppose, but a vast majority of headaches are from being dehydrated. Well, what if I have two different people? What if one of them is getting enough water and one of them is not? Well, then is it the medicine or is it the water level that's the problem? But if I'm good with drinking lots of water these months, I'm going to be good at drinking lots of water during these months. If I'm bad with water, I'm still going to be bad with water. So I'm comparing me to myself. So my habits should be the same between two times. The other one I like to use as an example is sunscreen on my arms. So I could put Sun Bum on this arm, and I could put I've lost. I'll just say Kroger brand. We buy the Kroger brand sometimes; it's super cheap. I put the Kroger brand on this arm, and I walk around all day. And then I compare my arms to my arms. And for those of you that are in my class and haven't heard this joke much time, I'm mostly Irish, and we burn. We don't tan. We just go straight to burn. Okay. And some of you, your arms would not burn. Why would I check my paley skinned Irish right arm versus your dark skinned left arm? That's stupid. It wouldn't make any sense whatsoever. But if I do mine to mine, it should be fine. And then if you're like, well, why wouldn't that eliminate all confounding? This is reaching. But let's just pretend for the day we went to Six Flags. Why Six Flags? Because this is how I can come up with an example. And you spend most of the day in line. Well, maybe I just spent most of my day looking this direction with the sun beating down on my arm. So maybe this arm would get more sun exposure. Or maybe I was in the car with the window down with my hand in the door in the window as I was driving down the road trying to look all cool and stuff. So maybe that arm was exposed when this one wasn't for a long period of time. So there could still be some confounding by that, but like that would be like just like what happened throughout the day. But as far as like skin type versus skin type, that part is has been taken care of. And again, that this is again the guy says block. I'm glad we know the College Board also likes match pair. There'll be match pair multiple choice questions, but there you go. That's pretty fast, but I think that's pretty good explanation. Okay, a couple of just little things. Increased sample size reduces variability. That used to be like one of the 5 most important things, but somewhere around the road that question stopped. I can tell you that when 80% of the world population gets a question right, they drop it. I believe that's one of them. But just in case, increased sample size reduces variability. Blocking reduces, or stratifying reduces variability as well. Multiple choice questions. I guarantee you there'll be a conditions question. Okay. And just remember, I mean, I know you know these, but if you really, what happens is you read the question, you don't really even understand what they're asking you to do. So what happens then, you go look at the answer choices, and then you're going to start noticing conditions. But it's going to be which one of them isn't met. And I'm telling you right now, the reason why this is difficult is because when we do FRQ, they're always met. Because if they're not met, then there's not much we can do about it. Although, again, side story, the guy thinks on the 2026 test number 6 is going to have a condition that's not met. If that's the case, you say this condition is not met, but I will continue with the calculations. Or it might be the large counts condition being a box plot because the large count isn't met. That was a student brought that to me as an idea, And I like that. And I like well, I don't like the fact I didn't come up with it, but I like the fact that somebody else did and then came and brought it to me. It's like, Miss Hughes, what about this? I'm like, oh my gosh, I should have thought that myself. But again, at least I can now share it with everybody else. But when it's which of the conditions isn't met, there's your 3 conditions, and just go through the list. Did they randomly assign? Do I know that the population is more than 10 times the sample size, or the sample size is less than 10% of population? And so is the sample not too big, and is the sample big enough? And remember, for this one, means 30, for proportion, fails in success greater than 10.
For proportions, large counts is less than 10, right? But for mean, it's
30.
Yeah.
Yep. Okay. Oh, and also, why did we have the 10%? So first of all, the reason we have random is to remove bias. Okay, without random. And so what happens if we do this without? Pure crowd. There's nothing we can do. You just toss it, and that's the end of it. Okay, 10% rule. Why do we have this? This is to ensure independent samples. So for our sampling distribution, we need each of those samples to be independent of each other. If the sample is more than 10%, then too many things show up in all the samples, and the samples start looking the same. So independent samples, that's a big one. They really like talking about that. Large counts, this ensures that the sampling distribution is approximately normal. That's why when this one is not met, what we do is then we show the box plot. Well, by the way, I always do, but it could be it doesn't have to be a box plot. It could be a dot plot, it could be anything. But if we see this and we can show that our sample shows no strong skewness, no outliers, there's no reason to doubt that the population is approximately normal. If the population is approximately normal, then the sampling distribution will be approximately normal. And again, for the 10% rule, if we don't have independent samples, then really everything goes wrong. But so that's pure crap too. Large counts, the standard deviation is messed up. If the large counts condition isn't met, the standard deviation will not be correct. That's actually something also with the if the condition isn't met from question 6 from the 2026 test. I was trying to think of anything I could think of. It's like, well, if the condition's not met, then maybe they'll say, well, what's the fallout of it? If these two aren't met, then you have to totally ditch everything and start over. If this isn't met, you can take that into consideration, but you have to know that the standard deviation is not going to be accurate, or it runs the risk of not being accurate. All right. So I got about 15 more bullet points, and then scripts for the or interpretations. All right. If they're asking you to explain how you would randomly assign treatments, and you say, we're definitely, I recommend the names in the hat method. I know when you had the exam and the answers, some of you memorized the answers they had. That's great. That's great. I'm glad you looked at them. I'm glad you got your hundo. That's great. When we don't know the answers ahead of time, just use the names in the hat method. Okay. So remember, they also, a lot of times they want you to label the participants. So I assign everybody a number 1 through 70. Then I put 1 through 70 on a piece of paper. I put them in a hat, mix well, and draw out 35 names that received treatment A. Then you have to mention that the other 35 received treatment B. And then you compare the results. Okay, one other thing I need you to say without replacement. Mr. Hughes dropped the ball. It does, well, we didn't talk about that, but it clearly indicated that you need to say without replacement. Okay, one other thing you can do is when you draw the first 35, you can say, I draw 35 unique. Maybe that's how you spell unique numbers. Okay, then if they're unique, then that means if I draw 22, even if I was doing it with replacement, if I draw 22, I don't ignore it because I want unique numbers. Again, let's just say without replacement. So put the names in the hat, mix well, and I draw 35 numbers without replacement. Make sure we get that E on that part right there. And yeah, I need y'all to pick me up on that one because I dropped the ball. Definitely dropped the ball on that one. Okay, I don't think you need to do this. This hasn't happened for many years, but you can turn your stat diagnostics on first thing when you get your calculator. When you do stat diagnostics, if you do linear regression, it gives you R and R squared at below the regression equation, but only if you turn stat diagnostics on. Here, let me grab. I'll have to just do it verbally. I'm not going to try to put the calculator up so you can see it. If you hit mode, and then it's the third from the bottom. And if you're really freaking out about that, come find me or your teacher, and we can show you that one. But that's just something I just want to point out. Make sure you know your formula card. You will get a copy of it. It is the font on it's a little bit different. It's shaded a little bit different. The stuff's in the same spot. But remember, with the formula card, you have to know what you're doing. You have to know where the item is on the formula card that you're looking for. But that formula card it's huge. The year I started training students on the formula card, we had an undeniable uptick in the scores. So hopefully you know how to use that formula card. Remember that we got several probabilities, binomial stuff here. We got a few other ones. Remember the probability of at least 1 is equal to 1 minus the probability of 9. I am promising you that's a multiple choice question. And again, sometimes you don't need this. You can find the probability of 1 and the probability of 2 and the probability of 3 and the probability of 4, but oh my gosh, this is so much easier. Plus, none is always going to be easy. It's 5 failures in a row. So it's whatever the failure rate is to the power of however many you need. That makes this so much easier. And again, I believe that they like to put this on the exam because a fancy calculator isn't going to help you with this. But if you truly understand that at least 1 is 1 minus 9, comes in, I don't want to say insanely easy, but pretty easy. And definitely one of the easier one of the easier probability questions. All right, and I have a thing about tree diagram. So what I used to say about the tree diagram is there's typically a tree diagram multiple choice question, although there's a couple of tests didn't have one. And you don't have to draw the tree diagram on a multiple choice, except usually you do. Okay. Also remember when you get to the end, these 4 are the and statements. A and B, A and not B, and etc. And again, you should look at for sure these 2. This one's from kind of a long time ago. Also, it was in question 6, so I didn't even look at that one. I looked at these. Both of these you can do a two-way table or a tree diagram. The guy says tree diagram in 2026, so I make sure you're ready for that. If we did not, we might not have a multiple choice one if it's on the FRQ. But if it is multiple choice, it takes you more than 2 minutes and 15 seconds to do this by hand. But that's fine though. We will finish early. Almost every single one of our students will finish early. Now they might still be looking over it, but you will finish. You will go back and backfill in the ones you didn't get. There'll still be time. So you can just go ahead and do this, or you can save it. Also remember, if a question is a lost cause, stop, pick your lucky letter, and move on with your life, and don't ever go back to it. Now, if you're doing a problem and you're like, oh my gosh, this is about experimental design, I remember it, but I can't remember it, skip it and come back to it. If you read a question and you're like, I have no idea what they're talking about, B, move on. Okay. And remember, the College Board says 8. You can do that 8 times and still feel good about your tests. And that's for them. I say 4 because we're better than they are. But 4 times, if 4 times you have no clue what the question is, you pick your lucky letter, you're fine. Don't you're in the good range. You're in the Mr. Hughes range, not in the AP stats or the College Board range. But and then another thing you can do is if you do that 3 or 4 times and you bail on a question 15, 20 seconds into it, you take that 2 minutes, you stick it at the end of the test, you can have 10 extra minutes at the end that instead of fretting about a question that's a lost cause, you can use it to go back and do the tree diagram. And then again this year, or for the 2026 test, I'm gonna try to use this video next year. For the 2026 test, you should probably know how to write one of those out and use it for an FRQ. 2018 number 3, 2019 number 3. And remember, you can find the scoring guidelines. 2018 AP Stats FRQ scoring guidelines, and slide down to question 3, and you can see those. But you need to do that, please. Mhm. Got that. Got that. All right, I need to do a computer. Oh no, I got it. All right. Now, when you take the exam, they're going to give you a piece of scratch paper. You may not write on the scratch paper until the test starts. But as soon as they say go, I want you to write this: alpha up, beta down, N up, power up, and gap up. Now remember, gap is technically effect size, but the effect that doesn't mean anything to us. But the gap between the value that we're trying to versus what it actually is. All right, and then you'll write this down, and then set it aside, and there'll be a question about power. You get this out. And again, if you've been following with me, that's what you need. And there's a couple of times where we had when somebody asked to go over it, and I was like, what if I wrote this down? And it was like, oh my gosh, the answer's C then. So just trust me. Now, not all of these are directly related. Like, for example, like raising alpha doesn't affect the effect size. Okay, so those don't go together. But alpha is directly attached to power. Sample size is directly attached to power. Gap is directly attached to power. So this isn't like perfect, and there'd be stats professors that would think I'm a jerk and idiot for writing this. But guess what? It gets 16, 17, 18-year-olds to get the power question on the AP exam. So I'm a big fan. Okay. Now, oh yeah, and then this gap business. Let's make sure we understand what gap is. And you know what? In power too, make sure we, before I erase that, we'll do gap. All right. So the gap, well, actually, let's start with power. So power is the probability of successfully rejecting the null when the alternate is true. You're like, okay, great. What does that mean? So let's say that I'm going to make the null as p is equal to 50% and p is less. So we're talking, actually, we'll say more. We'll say we do have a majority. Don't forget, majority means more than 50%. Usually they give us numbers. Sometimes they'll say something like majority, and we have to know that. All right. So power is the probability of rejecting the null when in fact this is true. So first of all, this has to be true. And then what's the probability that I will successfully reject? That's what power is. Okay. Now, if the gap, well, we're talking about the gap. So let's say for realsies, the true population proportion is actually 90%. I suggest that we are almost guaranteed to reject this and say it's over 50%, because this is so much larger. The gap between my cutoff value and the for realsies number is huge. High power. Very likely to reject it. But what if P was actually 51%? Should I reject 51%? I should reject 51% because it's greater. But what's the chance of me scooping a sample of this and getting a number or a sample that's far enough away from 50% that I would have statistical evidence? It would be almost impossible. It wouldn't be impossible. Like even if it's 40%, it's possible I could get a sample that would tell me the wrong way, right? But anyway, the gap here is 1%. The gap here is 40%. The power is going to be much larger if the for realsies answer is 90 versus if it's 51. And it doesn't have to be that extreme. It could be 52 versus 51. The bigger the gap or the effect size, the easier it is to reject the null and when it is true. That's the effect size. All right. Again, I'm telling you, this is cheating, but like legal cheating, not like cheating that This teacher cheating, not student teaching, student cheating, but cheating on student teaching is cheating is when you get the answers ahead of time and then that's why you got a 100. The teacher cheating is when I teach you something that isn't exactly what they want you to know, but doggone it, we sure do get the right answer a lot. So we're gonna do that. All right. So we got binomial and geometric, and we definitely need to go over binomial because the guy said that would be on there, and the computer output model, and my scripts, and all the scripts. And I'm not writing out the scripts, by the way. We'll talk through them, but I'm not going to write them all out. Then it doesn't appear there are only two scripts I remember them being on the board was slope and r squared. So we'll definitely make sure we hit those hard, but we'll go over all of them. And the scripts are multiple choice questions typically. We make you write them perfectly so you can get them right on the multiple choice, and you'll see, or hopefully you've been noticing on the other ones. All right. Let's do a binomial, but I'm going to do more the version we used to do, but that's fine. All right. So let's say that and we did weight of a moose. I'm just going to go with that. The weight of a moose, from the population, the mean weight is 1,000 pounds and a standard deviation of, let's say, 150 pounds. Okay. And then the question says, what's the probability that a randomly selected moose will weigh more than, let's say, 1,200 pounds? All right. Now, before I can do this, remember, first of all, don't forget your probability statements. The College Board rubrics didn't say anything about taking points off. I know they take points off for not putting those. And sometimes they talk about the correct boundary value. If they say boundary value, that's how you get the boundary value. So let's remember our probability statements. But before I can do that, I can't use X without defining it. So X is the weight of a randomly selected moose. And I'm not going to get all contexty here, but it'd probably be like the Alaskan bull moose or something like that. Make sure you get those words in there. Okay. So how do I find the probability that one moose weighs more than whatever? That's normal CDF. The probability is the percentage of those. So normal CDF. Lower would be 1,200. Upper would be like 10,000 or something insanely large. Mu is 1,000 and sigma is 150. Oh, and by the way, I have to say X follows. I have to state the distribution as well. Although I'm going to be 100% honest with you. I want you to write this. Typically, if we write this out correctly, that's okay. Now, again, at the beginning of the year, I made you do both of them so that if you forget one, you still got the other one. Or if for some reason they don't like, I don't know, maybe you write something here they don't like and they won't accept this, but you got it here. It's like I make you double cover everything on that one. And then we get an answer. Plug that one in. Let's actually, we'll go ahead and plug in the probability one. That's pretty hard. And I get 9.1%, 9.12%. Well, let's go with 9. And then you answer in a sentence. Again, I gotta be honest with you, that wasn't seeming to be a problem in the rubrics, but I would have you write this in a sentence. Now, if you want to cut that out for time first and go back and fill it in if you got time, I can get on board with that as well. Anyway, so that's the first part. Okay, then another one. This isn't binomial, but let's say it's what is the probability that we'll say 5 moose weighs, let's say less than, let's say at most. Let's say 5,200 pounds. Okay, so this one, the probability that X is at most 5,200 pounds. Pause. No. Can't be X. X is taken. That's not, we got to do Y. Okay, also, we have to figure out what mu of Y is in sigma Y. New mu and new sigma. Okay, so mu of Y, it sure would be nice, if it was just 1,000 times 5. But it can't be that easy, but it is. And remember, Mu is nice. It's mean, which sounds bad, but it's not mean. It's actually quite nice. And the standard deviation, we don't like standard deviation. So standard deviation, it's 150 for each one, but we have to do 150 squared plus 150 squared plus 150 squared 5 times. And then square root that to go back. And again, we're actually doing variances and then we square root it back to standard deviation. I don't want to write that. And what happens if it says 70? I don't want to write 150 squared 70 times. So what I do is do 150 squared times the number of them you have and square root the whole thing. And you might think to yourself, it's like, I don't like that. It's not made for joinment. It's made because that's how it works. And also you like it. Don't lie. I know you like it. So that's our new mu and new sigma. Then we come in here and we do normal CDF with our new mu and new sigma. Except of course we're not using these numbers. This was at most. I'm going to go ahead and set my lower at 0. You can put negative 1,000. It said what it would say is any reasonable lowered boundary is accepted. The upper would be 5,200. Mu is 5,000 and sigma is 335.4. Also, you got to write. Okay, mine's pretty sloppy. I'm not being graded. Lower, upper, mu, and sigma. Also, it wouldn't hurt to put the x's and the y's here, but they don't require it. And I will tell you this: if you put x here for y, they wouldn't like that. So in your normal CDF syntax, that's even a word they use anymore. That just do mu and sigma. They always accept just mu and sigma there. And see, if I was smart, I'd have these numbers ahead of time. I never claimed to be that smart. Oh yeah, and also, if you round, I would absolutely have you write squigglies. I don't think they'd take off for that. But again, in a vacuum, I would just have you write it correctly with the squiggly if you round.
The third deviation, I didn't understand that part.
All right. So when we combine standard deviations, I can't just take 150 plus 150. If I was doing 2 moves, I can't do 150 plus 1. But what I can do is I can square them, turn them into variances, combine them. And what I've done here, yeah, right. And again, it's just so I don't have to write that number out a bunch of times. You guys are lucky. We got a mod in here helping me out and taking the exam. So asking a question or two. So maybe I don't know. And I know this is difficult. So maybe that helped. But and again, if you could write that out and you can plug it in like that too. The problem is once this gets bigger than across the screen, it's really hard to track how many of those you typed in. So this is like an algebra trick so that I don't have to write all that stuff out. All right. So that's that. And then the binomial part. So I'm gonna go ahead and erase this, but I'm gonna keep the top one. Also, based on the guy's prediction, they won't do this, but they love this next step that I'm about to do. So we'll say, what is the probability? Hey, by the way, no abbreviations unless like LSRL for least squared regression line or GOF for goodness of it. Only abbreviations that have been claimed to be official abbreviations. Don't abbreviate anything else on your exam. Like if you write prop instead of sample or proportion, that it is my understanding that they take off. They don't like abbreviations. No abbreviating on your test, on your exam at least. Sometimes we're a little lenient with it, but you're not getting college credit for my test. Their test, college credit, do what they tell you. So what is probability that, let's say, at least 5 of the next 40 moves weigh more than 1,200 pounds? All right. So first of all, this is binomial. Why is it binomial? Because you said you were doing binomial. Great answer, but that's not what I'm looking for. Because I have established that I'll be selecting 40 moose, which is the plural for moose, which is fun. That's why I like using moose. You can also call it mooses if you want. I won't judge you for that. Anyway, so that's going to be binomial. Okay. Also, I need to remember, and it's the guy straight out said you will be defining a binomial variable, stating you'll do the state step. And I would also like to remind you that you are all horrible at defining binomial variables. All of you, even the really smart ones, and you know who they are, and the people in the room know who they are. They are too. You're all horrible. You're horrible, horrible at defining binomial variables. Now, as it happens, it's not that big of a deal because you only have to do it, say, I don't know, tomorrow on the AP exam, and then it'll be over. Okay, your life isn't over because you're horrible at this. But I need you to remember, like, man, I am no good at defining binomial random variables. All right, so I'm going to say x is, no, I'm not. I've already used x. So then I say y is, no, I'm not. So you can do z. I'm going to do b for binomial just because I'm a simpleton. Makes me happier. So b equals the number of mooses that weigh more than 12. I was going to say at least more than 1,200 pounds. And here's where you guys stink of the next 40. You have to include that. Let's see here. The question, we had one. Oh heck, I don't remember. It was it was the from last year's exam, and I at least went over one of those. But the probability question, it was about the how many rock songs there were, and it was, they said in 1 hour there's 20 songs, and then when they did it, they said the number of rock songs in the next hour. But then if you looked in the additional notes, it said instead of saying the next hour, you may say of the next 20 songs. So I like doing like that because then it's always pretty obvious. It's always the quantity of the things that are more or less than whatever number we're talking about of the group of predetermined amount 40. Oh, and again, the guy has that separate. That was separate on two of the previous 5 exams had where you had to define a binomial, and that was the part of it right there. Okay, and then you say B is binomial, and it tells you to state the distribution. You have to give N and P. It will not prompt you for N and P. So it's state the distribution, and then the part they don't tell you, but underneath the breath, with the parameters of interest. When we did normal, the parameters of interest are mu and sigma. So we state those. For binomial, it's N and P. And just geometric, I'm not going to go over that today. Maybe I should, but I'm not going to. Only N. I'm sorry, only P, because we don't know what N. Remember, geometric is I do the thing until I get my first success and then I stop. And make sure you know where those are on the formula card for the mean and standard deviation of binomial and geometric. Okay, one last thing. This is always tricky, and this is something, again, it might not be the setup, but they love this trick. The answer for part A is part of the work for part C. But we don't see that. We read this problem, you're like, well, what's the probability? It didn't say the probability. Well, we said the probability. But again, I get it. I get why that's confusing. That's why when I do these, I make sure I always put that one in there. All right. And then second bars, remember it's faster to go up to get to binomial CDF. Okay, that's weird. It did not prompt me for the information. It just said, okay, and then trials 40, P 0.091. Okay, now when I'm sorry, I didn't write that out. So we on this one, we're gonna say the probability that B is, I forgot, that at least 5 of the next 40. I think I want okay. So probability that B is greater than or equal to 5. And that's equal to 1 minus binom CDF I'm gonna erase a little bit here, sorry. Trials. P. Now the calculator says X value. And again, I need you to help me out on here because I kind of blew it. We only write, they don't accept X value unless it's PDF, a single value. This one would be CDF. So here, let's do that real quick. So if I did PDF 4, that means X is equal to 4 exactly. Exactly 4 PDF, and you write X value here. If it's CDF 4, that means we have 4 and 3 and 2 and 1 and 0 cumulative. So that would be X is less than or equal to 4. If I wanted X is less than 4, I do CDF 3 because I don't want to include 4 in my answer. I only want 3 and down. If it's greater than 4 or greater than or equal to 4, greater than 4 is 1 minus CDF4, and this is 1 minus CDF3. Now, what's up with that? So we got this number list 1, 0, 1, 2, 3, 4, 5. Okay, and this one would go all the way up to 48. I ain't doing that, right? So if on this one I want it to be, it said at least 5. So these are the numbers I want all the way to 40. The calculator only plugs in the number you tell it and goes down. Now, how do we fix that? Well, all of them together is 100%. 100% because we can only do what's possible, right? So if this is 70%, well, actually, I'm sorry, we wouldn't know this one, right? But if I know this is 30%, then I know this one is 70%. And that's why we do the 1 minus. All right. So that was a little bit of off, but I think that was worth going over as well. Okay, when we're doing CDF, I would like you to write upper bound. I'm gonna get that fixed for next year, but upper bound, and it's never lower bound, it's always upper bound, because whatever number you put in here, and I'm gonna put in 4, it does 4 and 3 and 2 and 1 and 0, and then we subtract those off. And this would be 40, and this would be 0.091. I think I'm gonna get a bad answer because I'm just making up stuff. Oh, no, it's not so bad. Okay, and I get 0.297. By the way, if this was multiple choice, this would be one of the wrong choices. It's the hundredths partner. Guess what happens? Guess how you get the hundredths partner? You forget the 1 minus. You forget the 1 minus. So this is equal to 0.703, but I do 1 minus 0.073 to get to 0.297. All right, so there's a binomial. That's a pretty good write-up. And again, I definitely want to do binomial. Binomial is probably the single hardest FRQ thing you can do. It's coming. It always does. But yes, please. Yes, please. We are mid at binomial. They being every other student on the planet is horrible at this.
Wait, so what part of that is the bin? I know the bin's like
Okay, in order for something to be binomial, you use the BINS acronym.
Yeah.
So that's B for binary, successor fail only.
I write binary. It's binary next to B.
Yeah, but you don't have to write any of that on the write up.
Oh,
It's just like a definition.
so just so you would know.
Yep.
Oh, okay.
And again, if you're trying to decide is it binomial, that's kind of the checklist to make sure it's binomial. But really, it's just if it's one of those nasty probabilities and they say there's a set number of trials. There you go. All right, computer output. I don't remember what it said. Yeah. You have to give me a second. I want to get this right. Oh, my computer shut down. Well, go ahead and get yourself a quick drink or something. I'm going to take me just a second to get this figured out. constant. It says constant. That's right. I found a question, so I actually write down the actual question. All right. So on the computer output models, it'll say constant. And then it's going to give you units. I'm just going to write, actually, what does it say? Hey, it's pounds. How about that? Okay. First thing I need you to know is this is the X units. That helps. As you're setting this up, when you're trying to figure out, wait, which one's the X and which one's the Y, the one in the computer output model, that's always the X units. And then I got, oh my gosh. Coefficient, except it's abbreviation, standard error of the coefficient, and then T ratio and P value. Okay, and then it's going to do something. I'm just going to write down some numbers. I'm just going to make up numbers. We don't need to watch me go back and forth. All right, so for computer output model. So first of all, that I need you to remember that we will never use those three. Oh wait, there's also on the bottom, it gives us capital S. It gives us, it says RSQ for R squared, and then RSQ adjusted. All right, and then I'll just do, and then R squared adjusted, we never use that, okay? This we only use with nasty problems that ask us to use to do more than we really want to. This one we'll use for the unit 12 multiple choice question. We'll go over that here in just a second. But and then these things and then these two we did back in chapter 3 or chapter 2, and that's what we need to know. All right. So for the least squared regression line, so let's say we're using the weight to estimate the height of a, I don't know, an animal. It can't be a person because that's way too small. So we would do the height hat, or maybe feet hat. It wouldn't matter. The simplest version they'll let you do underneath the hat is the units. So feet or inches or pounds or whatever it is. But we might do height hat, that's fine. So the height hat equals negative 16.04 plus 3.84 pounds. Or weight. That would be the least squared regression line. And that was not a problem. That was not a problem for doing that. But I do the constant. The constant is the number that doesn't have the variable attached to it. There's a little algebra for you probably didn't want. And then the number, this right here is the X units. The number next to it is always the slope. Okay. Another thing, and S, this is the standard deviation, the residuals. Here we go. Here's your first script. So I'm not going to go back and do this twice. When using the weight of the animal to predict the height of the animal, our predictions will typically be off by 5.2, and then whatever the Y units is, feet. That wouldn't be very good. But I think we want that number to be way, if the slope is this much, I don't think we'd want that number to be, but that's fine. So when using X to predict Y in context, our predictions will typically be off by blank. And then that's what S is. And also remember the units for S is always whatever the units for Y is going to be. Oh yeah, and also the standard deviation. If they ask you to interpret standards, anything in the standard deviation family, it's the typical distance from the thing. The typical distance from the mean, the typical distance from the least squared regression line, the typical distance from the predicted value. Okay, and if they asked us to do R squared, we would square root that number. By the way, you're going to be a little happier if you turn it into a decimal before you square root. You don't have to, but you'll be happier. I mean, not like for the rest of your life, but for this problem. So R is 0.65. Or is it? It could be negative 6.65, 0.65, not 6.5. Well, Which one is it? Slope positive, positive 0.65. When we had this one on the test, we told you guys it would be negative, and over half of my students put it as positive. So I very much like the chances of you being given R squared, figuring out what R is, and having it be negative, and only the smart, good-looking people are going to get that one right. So let's be that. Okay, and the other thing I want to go over from here is if they ask you for the confidence interval for the slope. If they ask you for the confidence interval from the slope, you're going to do it's so first of all, remember confidence interval is the statistic plus or minus the critical value times the standard error. The statistic is the 3.84, the results of the sample, plus and minus critical value. We'll come back to that, times the standard error. That's this right here. On a multiple choice, they're going to tell you this divided by the square root of the sample size, but this has already had the divided by the square root of 30 in it. So whatever that number is right next to the slope is the number you use for the standard error. So what I like to think of it is I take these two numbers and I just split them apart and input this in between. And then for the critical value, it's inverse norm, split the difference, or inverse t. It's typically t. It's almost always, as a matter of fact, I'm going to scratch that. It's always inverse t on a computer output model. So then, and I would have to know ahead of time, 95% confidence interval, inverse t, split the difference. And if this one, the degrees of freedom would be n minus 2. N minus 2, only for this one, but n minus 2. And then, which would be, let's go ahead and actually type that in. Inverse t 0.975, degrees of freedom 28. I'm going to pretend like the sample size was 30. And I get 2.048. And most of the time, that's what you need. A couple other versions I've seen it where they combine these two numbers together. I've seen it where they make it confidence intervals. I've also seen it where they only ask for the margin of error. And remember, critical value times the standard error is the margin of error. So then you would just multiply those two numbers together if they wanted the margin of error. All right, computer output. I believe I'm left with scripts. All right, and we're about almost an hour and a half in. Like I said, this really doesn't go much past hour and 45 minutes, and we start getting done. All right, so I'm going to write down all the scripts, but I'm not going to. I'm going to write down what they are, but I'm not listing them all out. It'd be all messy. You wouldn't be able to read it anyway. All right, so we have a script for slope, and so if you don't, of course, you can log off anytime you want. But if you're feeling good on these, then you should be fine. And we'll finish with type 1 and type 2 error, a little bit of type 1, type 2 error talk. All right, here's it. We got this much left. And I'm going to take a quick second. Make sure you get sleep tonight. It never ceases to amaze me. People come to these tests with 2 hours of sleep and they think that's smart. That's no. Some people say 8. I never get 8 hours of sleep. You need sleep. You need sleep. So make sure you get some sleep. All right. Slope. When we interpret the slope, for every 1 increase of x, we predict the slope increase or decrease for y. So if the slope is positive, I'd say for every 1 increase in blank, I predict an increase to the y by whatever the slope is. If the slope is negative, I say for every 1 increase, and it does say for every unit increase. So sometimes you can say for every increase. Yeah, that probably means for every 1. But let's just put in the freaking 1, please. Come on, help me out a bit. Okay. So for every 1 increase in x, we predict an increase or decrease to y to wherever the slope is. The y-intercept, when x is 0, this is what we predict for y. And remember, this doesn't have to make sense. So we had the McDonald's question way back, and it was like negative 40.6 plus whatever. And it was the predicting the fat based on the carbs. So you'd say a McDonald's beef sandwich with 0 carbs is predicted to have negative 40.6 grams of fat. And again, that doesn't make sense, but that's fine. It doesn't have to make sense for that one. Because again, you're interpreting what the number means. Okay, R. So let's say R is equal to 0.8. I would say there's a strong positive linear association between X and Y in context. If R is equal to 0.5, I'd say there's a moderate association or relationship, positive linear relationship. If R is equal to negative 0.8, I'd say there's a strong negative linear correlation between X and Y. That's R. It sounds a lot like, yeah, I never mind. R squared, we already talked about this, but it was on the guys list. So let's go ahead and make sure we do this one again. R squared is the percent, let's say, of the variation. I'm going to write this one out. Of Y in context that the percentage of variation Y that is attributed to the least squared regression line. That's an approved abbreviation. That compares, I don't know if that relates, I like relates better. That relates X to Y. And of course, X and Y would be in context. Right? That's on your exam somewhere. It's multiple choice or whatever. And again, remember, sometimes on the multiple choice, they'll give you R squared, but they'll actually ask you for R or vice versa. So be careful for that. Okay, as we already talked about, that's the standard deviation of the residuals. That the standard deviation is when using X to predict Y, my predictions will typically be off by blank. Okay, then the next one, the probability model, mu and sigma. So this is like where mu is equal to 0 times 0.4 plus 1 times 0.3 plus ... equals, or is approximately equal to 2.2 or 2. I guess I'm going to do 2.3. Okay, if they ask you to interpret this, again, they talked about this. I like the chances of this being on the FRQ, and then again, or FR multiple choice. So this one would be if I took many samples of the same size from the same population, or you don't have to say that, but if I was, it's the long count. You have to say many. If I do the thing many times, the average number of whatever it is would be about 2.3. And you have to say about there. That's completely wrong if you don't say about, because it's again, if I flip a coin 1,000,000 times, I don't get 500,000 of each, but I do get about 500,000 of each. Okay, and then sigma, again, I'm not going to do all this, but it's this big mess and equals 0.05. And so when we do this one, and again, it's the typical distance. Oh my goodness. I mean, I don't have to write, I didn't write it. That was weird. Okay, remember, it's the typical distance from the thing. Okay, but it's not many. It's every time I do the thing. If I do the thing many times, I get on average about this much. Every time I do the thing, I expect it to be whatever the standard deviation is away from the mean. And this is something, I didn't do this, but you would say away from the mean of 2.3, whatever units it is. But I didn't have you, I just said away from the mean, but I have been convinced that you also need to put the mean that's from this. Like I was thinking, well, why would you need to do that? Doesn't make sense. Well, that's called interpreting in AP stats, right? Why do you have to write it like this? Because you do. Shut up. Just do it. Right? We should know that. All right. So that's what we got. All right. Let's save p-value for the last. And you know what? We'll do it right now and we'll do it last. P-value is the probability that if the null is true, that we would obtain our sample or the sample or one that is more extreme. And for the love of whatever is holy to you, I need you to know what p-value. I need you to know that. I need you to understand it. There are multiple questions. They will talk about p-value and what it means, and it's really hard to kind of fake your way through that. You need to know what that is. But again, and that's why when the p-value is small, less than alpha, that's why we can reject the null. So let's say the null is that p is equal to 0.5 and the alternate is that p is greater than 0.5. If in fact the null is true, if in fact the container has 500 red marbles and 500 blue marbles, the probability that we would have obtained our sample that we got 60%, or a bigger one is, and then whatever the p-value was 0.01, meaning it didn't just happen by randomness. It happened for something else. What's something else? It was more than 50% red marbles. Say, well, why did you say it was 50% if it's more than 50%? We don't get into that. It's more, that'd be more like, not lying about marbles, but like flights being on time. For some reason we want to actually lie about that. But the p-value, and again, if the probability that we would get this or something more extreme is super teeny, then I suggest that that's not correct, and that one is. That's p-value. All right, again, we talked about power. Power is the probability that if in fact the null is, the alternate is true, what's the probability that I will successfully reject? So it's correct that it's more than 50%. What's the probability that I will actually get data to prove it? Well, prove it, but to be able to reject the null. And again, it's not really proof, it's just convincing evidence. Confidence level. When we interpret confidence level, so like if we said a 90% confidence interval, so 90% would be the confidence level. That would be if I took many samples of the same size from the same population. So whatever was done to get the confidence interval, if I repeat that process many, many times. But again, what I would have you say if they ask you this, or again, it's more likely this would be multiple choice and you're trying to match it up with the right answer. But if I take many samples of the same size from the same population, 90% of those intervals will actually get the correct answer. And again, what I mean by that is, this is the confidence interval. Again, I'm not even going to put numbers down to it. The next person or you do a sample from the same group, your confidence interval is probably going to be pretty close, but it's not going to be exactly the same, right? Because we got different people when we did them. And then somebody else does one, and somebody else does one, and somebody else does one, and somebody else does one, somebody else does one. And then we get one of these. All right. Did they do something wrong? Well, maybe. But so we look at the stuff and we decide they did nothing wrong. They did nothing wrong. What happened? Well, we're 90% confident that whatever the real number is going to be in those intervals, that means 10% of the time they're not. So if I take many samples of the same size from the same population, I create a confidence interval for each one of them. As long as I did everything correct, 90% of these intervals will actually have the real number in them. And its hundreds partner will not. And type 1 and type 2 errors. Okay, so type, again, let's start. First of all, remember a type 1 is if you reject, and type 2 is you fail to reject. So that helps us keep that straight, but that's not how we answer it. So type 1 is when I say no to this and I say this is correct, but it's not. So the evidence suggests, or the evidence, I have convincing evidence that the true population proportion of whatever it is greater than 50%, when in fact it's not greater than 50%. You can't say I rejected the null when I shouldn't have. They just give you no credit for no context. So, and you always talk about it in terms of the alternate for the type 1, type 2. So type 1 is, I suggested this, but in fact, it ain't that. A type 2 error is I say evidence does not suggest, or I do not have convincing evidence that the true population proportion of the things is greater than 50%, when in fact it is. So I didn't reject this, but I should have been able to. And again, remember the error isn't because you did something wrong, it's because you got that wacky sample. It happens. As a matter of fact, if we do things randomly, it is guaranteed to happen if you do enough trials, and you should do enough trials to get the right answers anyway. All right. And then this is for the 2026 test specifically. I don't know this happens, but the way it was set up, I think they might do this. So you're going to say alpha is 5%, and then they're going to talk about type 1 and type 2 errors. If type 1 is worse, okay, so I like to use the example, grandma gets dialysis, is the dialysis machine working good? A type 1 error is grandma gets bad dialysis, and type 2 error is the doctor fixed his dialysis machine when he didn't need to and he's out some money. Okay, grandma's bad dialysis is way worse than some doctor losing money. I don't even care if you're the doctor, bad dialysis, that's horrible. They don't need bad dialysis, right? So if a type 1 error is worse, what should you do to the significance level? If the 1 is worse, you should shrink the significance level. Why? Or how come? Sometimes why in math is kind of confusing, right? The probability of a type 1 error is whatever you make alpha. So if a type 1 error is bad, really bad, I want to shrink that down. Okay? Now, why wouldn't we just do that in the first place? It increases the probability of a type 2 error. It's not a one-to-one relationship, but it will go up if you make this one go down. What happens if type 2 is worse? Then you should bump that alpha up. That will drastically increase the chance of having a type 1 error, but it'll shrinken the type 2 error. Now, again, I bring this up only because it's question 6, and if it's not 2026, it won't be from question 6. You know, I'll have a different one. But it's outside the scope of the class. I have been suspicious of this being on the exam for years. Maybe this is it. And if it is, I've got proof of how smart and great I am because I just told you that the day before. But if it's not on there, I don't know. It's still something to think about. But again, the investigative task usually ask you to make some decisions outside of the scope of the class based on what you found. All right. Do you see the chat?
No. I think they're there.
What's that?
I think they're there, but I don't know how to get to the chat.
All right. Well, that's what I got. And it's an hour and 40 minutes. I said it's usually an hour and 45. It's the same list that I've gone off before. Get some sleep. Remember, we are the smartest group of AP Stat students on the planet. We're the most prepared and we're the best looking. It's not fair. I just need you guys to finish up and study. I need you to get some sleep and I need you to come and destroy that test. You know what to do, and we've worked all year on it. Cheaters are in big trouble, just like we want them to be. But everybody that's put in the time, you're fixing to get your payoff tomorrow. You should not guaranteed. You should finish the test early. Go back and check for context. Go back and check for units. When you get done with the multiple choice test, if you're done, and you looked over everything and there's still 10 minutes, don't just go read back through stuff. Give yourself 10 minutes to breathe and relax. And then maybe you can be first line, go to the bathroom. But I can't tell you, I do not get nervous about the AP exam. I can tell you right now, 73% of you are going to pass it. It would be better if we didn't have so many cheaters, but I can't fix that. Okay. Those of you that have done the work are going to get the payoff. Those of you who didn't, you won't. I have nothing to be worried about. I'm going to sleep great tonight. Don't worry about Mr. Hughes, but I need y'all to get rested. Have a good breakfast. Sometimes my kids always use that excuse to make me take them out for breakfast wherever they want. I got one taking the WAP test tomorrow morning, so we're going to McDonald's for breakfast. Bribe your way to a good breakfast. Have something good. Come early. Well, this is an afternoon test. Get down there. I'll be there to give you one last piece of encouragement, but I'm telling you, it's already over. We are going to absolutely destroy this test. I have full confidence, full confidence. I'm very proud of you guys. I know I rag on you way too much, but I'm a teacher and that's what I'm supposed to do. Otherwise, you guys get too overconfident or too complacent. But y'all are great. It's been a great year. It, like I said, it's already over. It's already over. That it's done. We're gonna destroy the test. All right.
I'm going to look through. Let's see. Is there anything important in inference significance? You should know everything in significance tests. Oh my gosh, your retracted message. I wonder what that was. All right. Also, I'll be in my room early tomorrow. I'll be at 8:20. So if you have any questions. Okay, now I don't know how to stop this.